Absolutely.
Yeah.
All right. Wait, and I'll give you the mouse. Yeah.
Thanks.
Right and full. Yeah. So, boy, that's one way to really get your body
Right back up. Get about enough of that.
Okay, well, let's get started. Nathan Minima is with us this morning, and Nathan has worked with Golden Valley since 2011. You've been correct. He joined Golden Valley in 2011. He graduated from the University of Alaska with a bachelor's degree in science and earned a professional engineering degree in 2015. So, Nathan, welcome, and
thank you.
Anxious to hear what you have to tell us.
Yeah, absolutely. Thanks for the introduction. So I wanted to give you two topics that we'll be kind of talking about and updating you on. One is the solar project that's happening this summer, just to kind of give you a little bit of background on the development of the project and then where it's currently at, the planned activities for the summer. And then I was asked to put together just a little bit of information on the battery energy storage system, kind of current performance, what's the status, future planned activities in that area too. So with that, let's see here.
If you give it a click.
There we go. Came back to life. Okay, so a few topics on the solar project specifically here. I want to talk about the Golden Valley's Sustainable Natural Alternative Power Program, so the SNAP program, which I'm sure you probably heard about in different degrees. So just a little bit of information on that. And then go a little bit into the decision-making process for the project. And then we can go into specs for the solar farm and financing for it and schedule. So the SNAP program, which is currently in place, was launched in 2005. And I find that a lot of people that come are inquiring about it don't know actually how much is actually out there right now. So with a few applications trickling in this spring, we're approaching the 200 member mark as far as member-owned solar, which can range from 25 kilowatts rather, and down. So, you probably see them pop up like on all the Princess Hotel by the airport there, and Quality Foods here off of Phillips Field. So there's been some small businesses that have been putting solar on, as well as we'll see applications at the member level at 4 kW. It's a lot smaller. Yes, sir.
You say 97% PV. What's the other?
There's some small wind. Yeah.
Oh, okay.
Yeah.
I see.
Yeah. And there's actually somebody who I don't know if it's currently active, but had a small run of the river in some creek that they have. They ran during the summer for experimental fun. But yeah, predominantly solar. And you can see also, like this summer will definitely crest the 1 megawatt level. So as far as the large project that's planned this summer, it really started out at the board level as a discussion about a true community solar project, which, if you read into that, there's a lot of community solar projects that have been developed in the lower 48 by companies such as like City Solar, a large-scale solar farm where you've got member buy-in. So, hypothetically, a member's owning several panels within a multi-megawatt farm. So that was where the discussion started. 2 vendors were actually approached and asked to give estimates for that project, and the cost per kW just came in way above and beyond what the board was willing to venture into at this point. From there, we developed a solar committee that had several board members, a couple internal staff, including myself, and then several members from the Member Advisory Committee, the MAC. So for a few months, we kind of kicked around what can we do on the solar front outside of a community solar project. How can we still kind of test the waters in this area? So that ended up developing into a 500 kW project, which we kind of deemed as a demonstration project, in that it would not be a true community solar project. It would be a Golden Valley owned solar farm where we would test the waters, demonstrate that we can do a larger scale solar project here in the interior, and from that gauge potential future expansion and how we could possibly roll that into a smaller scale community solar project. So we sent out the RFP end of June last year. We advertised it on the Alaska General Contractors website, and we also sent it to several companies who had heard about it through the grapevine, just from me asking questions to different people. So we ended up receiving 12 proposals from 4 different companies. We structured the RFP such that I didn't want to limit bidders just to an arbitrary 500 kW. I wanted them to be able to give me their best bid. So like I said, one of them, we received 6 proposals from one company at different inverters, different types of inverters. The size range varied a little bit. So they're all Alaska-based. Originally, we did have some interest from out of state, but they ended up backing out right at the end. Some key points we wanted addressed in the proposals was the warranty, both for the inverters and panels, O&M costs, temperature limitations on the inverters, and then because this was going to be a demonstration project and something we want to be able to easily collect and evaluate the data, we kind of specified a pretty, I think, robust data collection system attached to the project. And then also, of course, see in the bottom of the project evaluation there, the average cost per kilowatt hour of the project. So we awarded the contract December of last year to ABS Alaskan here off Van Horn. Jim had some really good proposals, both in cost and just kind of all consistency of his proposal. So, and that's been advertised, so that's kind of out there publicly. And I mentioned different proposals. We had 4 proposals from ABS Alaska, and we ended up going with Jim's option for microinverters, which are so on a large scale solar farm like that, you could have a couple different inverter options. One would be one single inverter for the whole farm, so a 600 kW inverter. Another would be like a string inverter, what they call, so they'd be like 50 to 60 kW, so you'd have 10 of these inverters per your strings, right? And these microinverters, actually one inverter goes and serves 4 panels, so you get a little more diversification, and they advertise them as you have a little higher capacity factor because, you lose an inverter, you just lose 4 panels, you don't drop your wire or a big chunk of it. And each microinverter is actually connected through a wireless network too, so for troubleshooting and diagnostics, it really makes it appealing. Sorry, there's a question. Okay, jump in if you had any questions along the way. So
Nate, I
yes,
just
sir.
have one question. Back on your last chart there, why did you only consult 2 different vendors? Why didn't you do like you did when you went to the 5?
On the community solar project front, I wasn't involved at that time. I can't speak to it entirely, but from discussions with board members that were involved at that level,
That's all you had.
yeah, they didn't have much, I think their options were limited. Went down to lower 40, like, well, who are the big companies? And those are the ones that expressed interest in giving somebody in Alaska a number. They may have consulted more, but we only received proposals from, well, they consulted. So yeah, those are the ones that expressed interest in providing us an estimate. Yeah. Yeah, no, thanks for the question.
You said they backed out eventually?
One company did, the others still had their number on the table, but it was significantly higher than what we could do a project of this magnitude at in-house. Several factors higher.
And price per kilowatt hour?
I should be getting there. Yeah.
Sorry.
No. If it doesn't pop up, I will remind me. I think it is here. So the total cost is going to be coming in at just over $1 million, 1.1 million. 3 acres in size. The foundations be a helical pier foundation type. We are going with fixed axis, so no tracking, fixed at a 45-degree angle. The total size, so there's close to 1,800 panels at 320 watts a panel, so it comes out to be about 560 kW DC, and the panel's 25-year warranty. Yes, sir.
You're going to fix them at 45?
Yes.
That is going to be a snow nightmare.
So that brings, no. Which is a good point. Good point.
Snow nightmare. I can't believe you. That's what you said.
That's ABS Alaskan's recommendation to us.
That is going to be a mistake. I can guarantee you that's going to be a mistake.
No, I mean, good point. So, but that'll roll into kind of some qualifiers here. So, more specifications here. So the microinverters, there are 440 of them. So you'd say that the plant or the farm outputs 440 kW AC. The collection's all done on the AC voltage level. So you can see there the 3-phase 480 volt. The inverter is also being warranted at 25 years, and the grid connection will be done through a distribution feeder that we have immediately adjacent through a 500 kW pad mount transformer. And then we'll have the capability for, for a user interface and data acquisition. And we're probably going to roll that into a link on the external web so that anybody can log in and kind of see real time. There's on the Golden Valley website now, you can see that for the Eva Creek Wind Farm. So it'll be a similar interface just for those interested in checking it out. So mentioned the firm cost. We got to have an EPC contract with ABS Alaskan. Golden Valley will be handling the grid tie of the service equipment like we would for any other member applied service of this size. We were able to offset the project cost through a USDA grant of close to $250,000. So that'll require some tracking along the way and reporting to them. But we got some good folks that are leading the charge in the financial department over there to offset the total project cost. So timeline, so right now we're currently in design. Really all the design has been received and is being reviewed. Most of the material is actually here or en route on the barge. So I think we'll be able to roll right into the foundations as soon as we get ground melt. So there's a couple contractors who are subbed out to ABS Alaskan will be leading the charge. And we've, per contract, we should be online by the end of October. So that is the goal. I thought I had some information on here, but talking about panel tilt and how involved do we have to be on snow removal. Part of the contract is that ABS Alaskan will be performing all O&M for the first 12 months, so that's part of the contract. But we're going to be working with him and really doing experimental on, okay, is 45 too shallow? Are we spending an inordinate amount of time on snow removal? Okay, let's adjust. So that first 12 months will be a real trial and error time where, Jim has great experience with numerous projects in the interior, granted not this size, but we can take what he's learned and kind of, I think, apply it here usefully. Other O&M, do we need to do any type of snow removal within the farm? What do we need to do for, knocking down growth and brush? I mean, we want to be out there as little as possible. We don't want to have high overhead costs. So we're going to see what we need to do over the first 12 months and then go from there, whether it could roll into a contract with another company, it could be a continuation of an O&M contract with ABS Alaskan, or it could be done in-house. We just want to do what's cheapest and least intrusive.
So in evaluating that 45-degree versus the tracking, I'm assuming tracking is with the sun.
So this will be fixed in that non-track. Yes, sir.
So my question is, so why at 45 degree? I'm assuming it's because of maximum sun time allowed?
Per Jim's recommendations, yeah.
And then the other question is, who then evaluated the proposals to say, okay, let's go with that?
Right. No. So you see, you had companies from Anchorage, from here in Fairbanks, and everybody's using different capacity factors for their farm, right? So we worked with each one individually and kind of evaluating the end of the day installed cost per kilowatt and cost per kilowatt hour, really equated the capacity factors to give it a level playing field so we could evaluate based on, well, we know whatever farm's dropped here is going to have the same performance in that it's where it's located, right? And actually all the proposals came in between 40 and 50 degrees mounting angle. So that was at least all in that kill zone, and that was from several solar companies in Anchorage and then the 2 companies here in Fairbanks.
That is interesting because on his point, I have neighbors, I mean, they're almost straight.
Right. No, yeah, more like
And they're all
80.
south-facing to switch.
Mm-hmm. Yeah. So it is I mean, there's definitely much talk about that. It's nice that this, the racking here is manually adjustable. So we have the capability to do it. It'll just be, what's our baseline? Where do we start? And then what do we adjust? Yeah.
So why behind battery energy storage? I mean, was that just land you owned, or was there?
Yeah, no, originally we were looking at other properties, but it was already Golden Valley owned, and it's actually like a EPA brown field for Alyeska days. So yeah, it's kind of determined. Well, our potential resale on this is not very good anyway. We're kind of use it for storage now, and it was kind of low hanging fruit for a place to put it. And, you know, good southern exposure there too.
So total days of sun, number of days of sun versus, let's say, Anderson or somewhere else. I mean, was there some discussion on that?
We were looking actually all along the rails of the road belt, you know, where we could drop it all the way from Salcha to Nenana, you know, in that area. But the board had this being kind of a big solar project kickoff, you know, they wanted visibility. So this kind of won out on that front as far as somewhere further out of town. And already being Golden Valley owned property, we save some costs.
It's from Nathan. Just a comment.
Yeah,
We did have Corey here earlier, and he did make that comment about visibility for the community to see that.
Yeah, that ended up being a
And
key
the battery
decision
stuff.
factor for putting it in town.
Battery stuff.
Hard to get a word in across.
For the future, this is not a highly visible site, but I think it'd be a good site would be on the south side of the landfill. Property that's not high, it's got great exposure, there's nothing in the way,
Yeah.
and anyway, it's not gonna be used for much else, and it's growing all the time.
Catching a lot of sun, yeah, right?
Yeah, that's a renewable resource. Garbage. It never stops.
Yeah, you might even get some methane off of it.
And I thought I had the number on here, but so of course it all comes down to how you evaluate it, right? But you know, you assume a capacity factor, which what we've seen on our member-owned solar is between 10 and 12%. So we use 10% for the valuation factor. You're just going to give a worst-case scenario, and then assuming a project life of 25 years, and some assumptions on our interest rate. We're around about 24 cents per kilowatt hour. The nice thing with a project this size is that we don't really have to worry about regulation. You know, if we've got a larger project, then we've got to attribute costs for generators to regulate this variable resource. But 500 kW is kind of just noise in the turbines, so they can handle it without assuming an added cost.
And then you don't have any land costs.
Correct. So that'll definitely be something that's going to be evaluated monthly, annually. Okay, is it doing better or worse than we thought? And then this will be communicated to the board and their decisions on if they want to have us go out and expand or grow it at all. Well, that kind of concludes the information on the solar project. If there's any other questions?
Just one other question. So then, how long is the GVEA going to study this?
Yeah, I've been asked that at other presentations. I'll likely be reporting to the board, I would guess, within like the first 6 months, and then the 12 months. And I would assume within that, within 12 months, maybe you get an anomaly bad summer, but the first 24 months, I would say you kind of starting to get a feel for what it's going to be doing. But that'll be totally I'm not sure what the board has planned and what their thought process is, if they're going to immediately want to go to expansion or try to convert it to a community solar. I would think those would be their two key things they're going to be considering.
I've got a question. You mentioned 24 cents. I would expect that would be higher in the winter months.
Yes.
And in the summer months, it would be less. So in the computation of that 24 cents, have you averaged that over the season? Or how did you figure that 24 cents? Because there's going to be some real costs in the wintertime, which, and I have kind of a question that goes in with that. If we're to get natural gas, and we can get our energy down basically to 15 cents, would you say? And then you come in onto the grid with 24-cent electricity, you've actually cost the consumer more than if you didn't have that grid.
Yep.
So how do you, has the board or you figured this in, how do you figure this in for the future?
No, I mean, you're spot on. So let's say like wintertime, your capacity factor is more like 4% or worse, right? And then summertime, in reality, it's maybe more like 18 or 20%. But over the 12-month period, with what we've seen in all of our SNAP solar projects and what you can see from the proposals received, everybody was right in that 10 to 12% capacity factor over the annual average. So that's where that number is coming from, is what is our annual average energy production going to be, and then take your capital cost over 25 years with an interest rate, and that's where we came up with that number. And yeah, as far as like consideration for, okay, well, I mean, and even 24 cents is pretty close and a little bit more than where we're at right now, right? So I mean, it's definitely on the board's radar that this is expensive power. I think we can all yep. I mean, otherwise everybody would be throwing it up all the time. So it's right at that tipping point. So they're going to be considering that too, as far as future growth. Okay, we got natural gas now. Well, then this kind of slides off the table versus if we're burning oil and it's $150 a barrel. So there's maybe the two extremes, right, of where power costs can go in the interior in the future. So I would expect the board to be fully on board with that. They're not going to want to stand before their constituents and say, yeah, we spent $10 million on a solar project that's 10 cents more per kilowatt hour than natural gas generated energy. So I think it's definitely on their radar. We were able to get it down to that 500 kW project. Initially, even the Golden Valley owned was kind of directed by several key players on like 5 megawatt level. Like, okay, well now you're at a 10 times the cost, and nobody wanted to expend that kind of capital cost on a first introduction to large scale solar up here. So they wanted to keep it at that smaller scale level for this initial test bed.
That 24 cents is with essentially your 1/4 capital cost covered by the grant. Yeah.
That is without being considered, correct? Yep, right.
Is it also without the base rate portion of? That's strictly the cost of solar production?
Correct.
So on the total bill, if you were going to get a bill for it, would be plus your base rate?
Oh, right, like not just your cost of power. Right. No, this is
We're only talking 30.
Oh, and then I don't know if you were in here earlier too, but regulation costs. If you got a bigger, larger solar farm, so then exactly, certain user distribution system. So this will just be dumped in, and because of its size, it'll be noise on the system as far as regulation and spreading that energy out over your distribution costs, so your cost of power. Yeah.
Oh,
It really boils down to location as to how much sun you get, whether it's.
You're in Fairbanks, Alaska, you're only gonna get so much in the wintertime.
Well, you know, there
With very
are
low
some
angles.
installations that are getting over 100% of the rated capacity of the equipment because of their location.
Well, then you wouldn't need any batteries.
And
You're getting over
so
100%.
10% is a very conservative estimate. And you've based all your calculations on a very conservative, and I understand, engineers do that. Because they don't want to make mistakes. Better guess low.
Exactly, no, this is for evaluation fact, and like I mentioned, knowing that that is the average, 10 to 12% is the kill zone for what we've seen on member-owned solar, but like you say, location, well, you got some solar panels up on a house on whatever, skyline.
Becker Ridge Road.
Get someplace where, you're in the trees and stuff, so you can knock it down, but that's what it's average over the whole Golden Valley service area for member-owned solar, that's what it's.
Have you guys thought about that, concept that, recently I've heard that the refractive light off of snow actually enhances the performance of solar panels? Is that something you guys?
Yeah, like March and April are the beauty months, because you get the temperature.
Not necessarily shining it at the sun, you might be somewhere in between.
Yeah, and the thing is, I guess that we're looking at avoiding, we'll see what the O&M costs come in at, but we don't want to have some guy fully on staff going out there babysitting it. Or we don't want the O&M cost to be high. So we want to find a good, best medium ground and hopefully leave it there.
They're fixed in their position.
They're fixed in position, but adjustable, manually adjustable.
But Nate, in that topic, and then going to Mike, then, these combination of these topics that you're talking about, depending on where in the future we do locate somewhere else, then all those factors you're talking about are gonna be out the window. The angle of the degree is gonna be different because of the location. No?
Not really.
I mean, you're at a latitude here. I mean, you got a lot of,
Well,
the plus or minus, on an annual basis, solar radiation varies by plus or minus 9%. So you've got a window of almost 18% to design your output from. So this is a pretty ideal engineering design option because you can be off by 5% and it's just in the noise, just like you said. So, one of the crucial things though is tilt. I mean, because of the annual variation, of the sun angle and the solar radiation reflection off snow, tilt's crucial. If you have, I did a calculation and I wrote a book called The Solar Design Manual for Alaska. And we did an optimization for what the difference is between an annual output at 60-degree tilt versus an annual option at vertical, right? So that you get maximum reflection in the spring. And the difference on an annual production rate, it's not the same time of the year, same rate at the same time of the year, but on an annual sum, it's only 1% difference. So in Fairbanks, there is really no penalty, considering that the annual radiation could vary 18%. There's no real penalty in mounting it on a south wall. You have no snow problems. So that could be a part of your design equation.
Can I expand on what I was trying to say then? There's a guy out in Chino Hot Springs located on the north side of a pond, large pond, gravel pit. And he gets reflection all summer and albedo all winter, and there's nothing to the south of it, no shadow until the Alaska range. And he's the guy I'm talking about in terms of getting, he had to buy bigger inverters after he started producing more energy than it can handle. So I think we need to look for those opportunities. We got water and we have sun in the winter time, and we have snow in the winter, and it's running at a cooler temperature, so it doesn't have to dissipate heat while it's generating energy. So there are a lot of further, heretofore unknown aspects on solar that we hadn't tuned into.
Sure. I'll mention too, we're talking about like performance and how are we gonna maximize it. The contract has a performance clause, if you will, such that it's beneficial for the contractor to maximize the performance over that first 12 months. So I expect changes to be made over the first 12 months. This was, us as non-solar experts really putting out an RFP and saying, here's what we want to do. Obviously, we want to maximize our performance. So that's be something over that first 12 months where we'll be making changes guaranteed. What they are right now, I can't say, and don't know what they will be. But we will be working at maximizing that performance. And if that's an angle adjustment, if that's we need to be out there removing snow once a month, what does that cost for labor costs? I'll be part of that, maximizing it over the first 12 months of service.
Did you get any other proposals that were like significantly bigger than 500 kilowatts, or can you say?
Yeah, no, I want to say the largest one we received was right around 700, and everybody was, excuse me, was giving an option that they could maximize their equipment. So if they had a grid interconnect panel that was sized so you could maximize its application at a larger kW, that's what they came in at. So, and that being said, there were some that were smaller than this proposal that we went with too, as far as nameplate kW. Okay, I was asked to kind of put together a few things about where the battery energy storage system has been at and what's happening. I'm sure you guys have heard the fun facts before, but so there's, as you know, close to 14,000 filled nickel cadmium cells. The whole facility there is 1,500 tons, and the capital cost when it was final commissioning was 2003, so it was a $35 million project. For 2017, I pulled the performance. It was kind of a higher year as far as preventing outages. So we had 72 kind of major system events that it covered. So if, you run the numbers on the energy that it output, you can say that, you prevented 6 outages per meter with the total energy output, or member outages of 280,000. So I would say that'd be in the top 80% as far as years in compared to previous years is how much it's covered. And that's just the nature of weather and events even down in Anchorage and such that could knock out the intertie. So we are looking actually near term some upgrades out there, like any control computerized system, the limited lifespan. So we're kind of approaching the point of some key components of the control system going obsolete and the contractor, ABB, not being able to support us anymore. So we're looking at a control system near term, as a near-term fix for that, and that'd be an ABB project, likely starting the end of this year and rolling into next year. So that allows us to really keep the current system functioning. And then in light of Healy Unit 2 coming online, we may be looking at adding additional strings. Originally the BES was sized so that we could cover close to 50 megawatts for 15 minutes from here in town. With not having Healy 2 on, our transfer that we're going from south to north is large enough such that we can usually cover it with the current BES size. Unit 2 coming online, all of a sudden we've got 50 more megawatts coming up the intertie into Fairbanks here, so it leaves us more vulnerable for outages should that intertie trip. It's been mitigated a little bit with having the 2 interties, along the parks, and then the northern intertie out in the flats. It's going to be a large capital cost, so there'll be more evaluations made and before that decision's finalized. That'd be more like a 3-year plan, I would say, before additional strings would be added. Other than that, it's, I do tours out there every now and again, and people are wanting to see, like, well, there's nothing happening out here. I'm like, yeah, no, just sitting there. Nothing fun to show you, but I guess that's good. It's just been idling along and really haven't had any, over the the past several years. Any issues, failures of any kind, so.
That's, roughly one event every 5 days, that's pretty significant.
Yeah, when you actually look at how much it's putting out, it is significant.
Yeah.
So it responds to system events on a frequency power curve. So some of those events are events down in Anchorage where an Anchorage generator tripped that would cause a reduction of power transfer capability up north. So kick it on until they can hit start on the North Pole turbines. So
You have 72 events were covered. How many were not covered?
all large, how I quantify large, if there was a system event large enough to decrease the frequency to trigger the curve, it responded. So it covered all of them in that regard. However, it's really just looking at generation and transmission disturbances. So like a distribution transformer tripping offline, it's not covered. So there's more events on the system than that. However, it responded and covered all 100% of events within its parameters that it should have responded. There'd be the occasional time where it just had an event and it's discharged enough where it can't respond fully. Still will try, but looking through the data, I didn't see any for 2017. They were spaced out enough such that it was ready to go.
Well, we've, this has been a tough year as far as outages. One of the big problems, of course, has been the right-of-ways and the heavy snowfall and ice. And I think the best batteries have helped. I mean, once you have problems as far as the transmission lines or breakdowns. One question I had is, how long do those batteries last? Do they have to be replaced periodically?
So they have what they say, 20 to 30 year lifespan, right? But so they were put in 2003, and then everybody's like, So the battery manufacturer and their representative, I guess I'll say, comes up once a year in the springtime, normally like beginning of May, and we switch out there's 4 strings, so we switch out one string at a time. We go through and we're checking, fluid levels on all of them. If there's ones they suspect as being problems, they'll check, check voltage, check resistance on them. So we're constantly looking at it. Once a year at least, we're running and the battery manufacturer kind of runs what they call a state of health, looking at, resistance degradation and such, the whole chemistry of the battery, to see where we're at on that lifespan. 2 of the strings are actually newer. They are right around like 65% state of health. It's kind of a, qualitative way of saying it, right? And the other ones are pushing more down in like the 25% range. So we're going to be at a point where a decision will have to be made too on upgrading these, and that may or may not affect this additional string discussion, right? Potentially we could upgrade our 2 older strings and prolong life. Right now, we often size or state the capacity of it based on how much can it give us for 15 minutes, because the 15 minutes is how long it takes to get a turbine spooled up. So if we have a system event, we only wanted to put out X number of megawatts to give us 15 minutes of runtime. If we just dump it all in 5 minutes, we still dump all the customers because the turbine's not spooled up yet. So right now we can do 27 megawatts for 15 minutes, and that's a moving number based on the state of health of the batteries. So that number, even since I've just been employed at Gold Valley, slipped from like 29 to 26 and a half, so that's going down. At some point, you got to say, well, okay, we've got to do something to bump that back up so we can keep member outages down. I mean, the flip side is, okay, it doesn't respond well, then people's lights are shutting off a lot more frequently, and that was the whole reason it was installed, was to prevent people having to reset their microwave.
Yeah. The batteries, can they be rebuilt? I presume they can be rebuilt.
So, yeah, the batteries came from Sweden, Saft, battery manufacturer. We've already talked with them, like, okay, if we want to do this, how's this going to work?
Yeah.
So their proposal would be, they would fly us in new cells, either for a string replacement or an additional string, and they would take the whole string back with them.
Mm-hmm.
So we wouldn't be dealing with, recycling. Thank you.
Mm-hmm.
On the old batteries, they'd be coming back.
Just as if you went to Napa.
Yeah, get cord charge and, yeah.
See, the, solar farm is adjacent to that.
Correct, so,
Is there a connection?
there is no connection. There's no connection, no, it just happened to be right there.
When you're talking about these 72 events, are some of those, would that involve like, frequency regulation and voltage regulation only, not necessarily a direct short, but within your 5% plus or minus?
Mm-hmm.
So basically, you're firming up the grid to keep it maintained at 60 hertz. Would that be a typical coverage for the battery, or is it, there's a short, we replace the power with this?
No, so some of those events are frequency disturbances caused by, say, loss of generation outside of our service area, Anchorage.
You're stabilizing the grid.
Yeah, however, those 72 events do not cover, I guess I'll just say small events, and that you can kind of think of it as that the control system has a small bandwidth where it's constantly, it's called the power system stabilization mode. So little things happen around. If we have even like a distribution, let's say a couple distribution breakers open up, all of a sudden you get a power swing in the system, the BESS will respond to that within a tighter frequency band. That's not counted in that 72 events. That's happening continuously.
Okay.
The 72 events is if it's exceeds the larger bandwidth.
So a certain amount of regulation going on, just under the radar.
Under the radar, right. Yep.
And how's maintenance? Because it makes me think if it costs $35 million, it might be $1 million a year, but it may be so quiescent, just sitting there relatively idle, nobody walking up and down the aisle.
Yeah, correct.
It may be pretty good on.
Yeah, I couldn't tell you just because I don't know what the annual maintenance is. I'd be guessing. I have a feeling it's right around like the 200, 150K range, but we do not go in there about once a year unless something. I don't know if we've done that about one time in the past 7 years. Like the strings are closed in and we don't go in there. I mean, it's an unmanned site. There's nobody there. Once a month, somebody will come in and kind of check the numbers, doing a monthly check, but unmanned and low on the maintenance side, yeah. We're currently just wrapping up what we call a battery monitoring system. The system came with a sampling system that was built by some company out of Philadelphia who's now obsolete. So as the equipment failed, it's like, well, chuck it in the trash because there are no more, which is unfortunate. But that gave us visibility at electrolyte levels, voltage, temperature of each cell. So you could kind of do some preventative O&M based on what you're seeing. So we had to really search the whole country to find somebody who could help us with a solution to gain some of that back. We went with a much more simplified system where we just have temperature and voltage, which we've kind of found out through the old system was our key indicators. So we'll have visibility at that level here within the next month. We're kind of hoping that helps us in aiding the decision process on replacements, additional strings, and maybe preventative O&M.
And it was the biggest, is it the second biggest one in the world now?
I haven't been tracking on it. I know there was, last I heard several months ago, there was 2 or 3 that were larger than it that were in construction. So we might have to take down our Guinness plow. So that was, yeah, last summer there was 3 in construction, so we probably can't claim it anymore.
Were the other systems being used similar to what this system's being used for, or was?
They were, I believe, all lithium ion, actually, so they weren't.
Same kind of regulation issues though?
So this being a, you know, electrolyte filled nickel cadmium, your state of health of the cell is greatly affected by a number of cycles. So the system was really made to do these periodic deeper discharges with adequate time to recharge between events. Whereas the lithium ion, these new ones that are coming on are, I think, more structured around renewable regulation. You know, lithium ion can sit there and its state of health is, or the number of cycles you can give a lithium ion over its lifespan is way higher than a liquid film, you know,
More like a cell phone battery.
Yeah, exactly. So you can sit there, you know, the wind's doing this and the battery is doing this, and you're just idling along. So this was more for system reliability, you know, for the interior, cover large events, prevent member outages. This cell wouldn't be the ideal battery for regulating renewables or wind.
Has Golden Valley given any thought to compressed air storage for regulating, not for emergency uses, but for regulating, you know, storage?
I've heard it discussed. I think maybe the thing I've heard more so is lithium ion paired with maybe a flywheel. CEA put in a 2 megawatt lithium ion flywheel combo that I think it was fully grant funded. That's either federal or state, that they're playing around with using it to regulate Fire Island.
It seems to me where we have this huge temperature differential between the surface and, say, 1,000 feet below the surface, that compressed air would be at least worth a close examination. That would have a high capital cost initially to build the chamber, but capturing that geothermal heat could be significant, reducing the cost, both the capital and the operating costs.
I think one thing that's maybe kept them away from looking at potential regulating resources, like, you know, you mentioned compressed air, you know, you got this lithium ion flywheel, you know, all this technology right there, is with Eva Creek, we've kind of, let's say, close to maximized our wind penetration for a system of our size. You know, right, we got 25 megawatts of wind on a summer interior load of like 150 megawatts or less. So it's a significant portion where it starts really skewing with how can we regulate this wind with that type of system load. Just don't have enough generators. We don't want to run a generator just to regulate wind, and then your cost goes through the roof. And Eva Creek's been a great performer and at a good cost, but something will have to change before we could be putting more wind on the system. We're regulating Eva Creek with the turbines that we have running, so there's no added cost there. If we did more, then we'd be at a point where we'd have to be investigating that. So I think that'll kind of hinge on their decision on what kind of renewables to implement in the future. And then those things would come onto the table pretty fast for discussion.
Other questions?
Yes, sir.
Can I go back to the PV for a while?
Yeah, no.
How much size variation did you look at? Did you always kind of limit it to 500 kW or I mean, if you went to 5 megs, kind of. Thing, but I think it would probably dramatically affect the cost.
Yeah, up to a megawatt was kind of considered as part of this project. So my role in it was hey, we need to put together an RFP for a solar project, at least 500 kW. But, so then I started talking with suppliers and vendors and found some, other RFPs for similar sized projects. And my thought along that is I didn't want to just give somebody some arbitrary number just out of thin air and say, thou shalt build to this number. I wanted to have some guy say, well, I can maximize my system at this. And that's what I wanted, because it had the cheapest cost per kW. Because the board was not interested in just having something at 500 kW, but what was the installed cost per kW, right? And the cost per kilowatt hour of the project, life of the project. So, however, even though the RFP was structured kind of open-ended like that, I didn't receive one that was a proposal over 700 kW range. And it had, because of the equipment and I guess a little bigger footprint, it just was quite a bit more installed cost per kW. So I was able to provide the decision makers with the numbers for the various proposals I received and kind of give them the direction to proceed on this one. It wasn't the cheapest, but wasn't the most expensive either. It did have the lowest cost per kilowatt hour of the cost of the project.
Would you care to comment on, and this was a board decision?
Sure.
Maybe you wouldn't. But would you care to comment on why they didn't choose to go with a publicly owned option or a subset?
Mm-hmm.
I mean, if you let the public take the risk, a lot of things go away for GVEA's board. And you sort of have a subcontractor doing the job. I mean, there are models for that.
True. Matter of fact, Homer Electric had something on the table. There's an article in the Peninsula Clarion, I think is there. You check it out. But they had a project, they were trying to do just that. They kind of advertised it as, hey, we want a IPP, an independent power producer, to come in and we want them to build a megawatt solar project. And same thing, kind of takes the liability off, co-op, and puts the risk on them for their performance metrics they provided. The risk is off. You maybe get a little larger project and you're just specifying what you want. And it looks like that was kind of falling through the cracks, I think due to a board vote actually. But right, that is a model that exists. It definitely was talked about. I wasn't on the inner circles of the final decisions, but that was discussed. It was also discussed, hey, could we meet this solar requirement of getting so many kilowatt hours of solar onto the system? Could we meet that by doing several 100 kW systems spread around the interior or Fairbanks? We were talking with the borough, had some ideas on there, putting solar on top of borough-owned facilities, so that was discussed. But that was definitely at the board and key borough, official discussion. So how that all ended up fleshing out, I'm not sure. What the final, the reasons those other options were removed from the table. I wouldn't have had to do this project, so I would have been okay with that too, but
See, Golden Valley is nonprofit, so you can't take tax credits. Is that correct?
That's another key reason, right?
Did you look for an investor that would pay for the whole thing in order to get the tax credits?
No, we would have been in the same boat with the borough. There were.
It wouldn't be with an IPPF.
Right.
And, you could, instead of forming you could form an LLC and have it be publicly owned.
We explored it and ended up not getting a good option to move forward. But yeah, you save, 30% on top of, knock that off your costs or whatever, and it's a big incentive. We kind of were paralleling past some of that investigation. We had this REAP grant application in, which would have not been credited if we wouldn't, as a co-op built project, right? So that would have kind of come off the table, and then it would have been replaced with something else. So there's a lot of numbers getting thrown around, and end of the day, this is deemed our best option for getting the solar on the system as per the board's directive.
I might have missed it, but was there a cost per watt installed capacity? I mean, did you drill it down?
Yeah, I wish I would've put it on here, but, you know, so we're at 1.8.
Easy way to compare.
Yeah, yeah.
apples and oranges.
It's, I wanna say like, my mind tells me 187, but $1.87 a KW, I believe. Oops.
Can I see the poster? Okay, people who are interested in clean energy, there's on April 10th from 7 to 9 p.m. at the Cold Climate Housing Research Center, a clean energy update by Chris Rose, Executive Director of REAP, that's Renewable Energy Alaska Project. Some details are here if you're interested.
I'll just piggyback on that. The USDA grant was through the REAP program.
But that was America, Renewable Energy America.
Mm-hmm.
This is Renewable Energy Alaska.
Oh,
I don't know
okay.
if it's
Oh,
a subset
same acronym?
or a play on the acronym.
Yeah, weird,
I don't know.
okay. Yeah, no, this is Renewable Energy for America program, correct?
I saw
No,
that.
yeah. So, yeah, it was about $1.80 cost per watt. Cost per watt. Mm-hmm.
Were there any questions on the phone?
Okay, Nathan?
Appreciate your time. Thank you, yeah.
And so we will have, next week, we'll have David Prusak talking about the LNG storage tank that's being built. He'll have a panel and a team there to answer any questions you have there. And then if you're interested in more on GVEA, we will have Corey Borges in here on April 24th to talk about the impacts of the MLMP sale to GVEA and then an overall update. So, yeah, thank you guys for coming.
Thank you. Well, Scott, take care of yourself.
Yeah, of course.
Don't take another spin.